Hi, Chris Guzmal here. We have this error. We have an array index out of bounds error, as I'm highlighting over here on the right. Um, and the index is -1. And I did stare at the code for a bit, and I didn't really come to a firm conclusion. And really, staring at the code is not actually, I mean, you want to stare at the code enough so you kind of get your mind in a place where you kind of have an idea of more or less the way things should be going. But I think it's best just to get information, and so that's what I'm going to do. I'm going to go ahead and print out AR. Okay, and I also want to print out start and end. And this is going to be a little bit cryptic because there's not going to be any spaces, so I'm going to put in a little bit of prettification by saying end there and saying start here. So this is just going to show me, I hope, what the arguments are to the partition method before we go in. And let's go ahead and also indicate, find out what a pivot is. So, well, what does partition return? And that should give us the information we need to figure out what's wrong. I'm getting rid of code. So there is a thing I want to name. I want to name it pivot. You'd think there'd be something automatic that would do this for you. In fact, it's called a debugger. But again, that's background knowledge that a beginning student will frequently not have. So we're doing the print lines. So hopefully now we're just going to be seeing what the array start and the end is as passed to the partition method here, and what the returned pivot value is. Oh, let's also find out what the array looks like afterwards. Okay. Because it's going to be presumably different. Okay. Okay. So that gives us the partitioned array after the partitioning. So those two print statements will hopefully give us some insight into what's going on. And that information is printed up here in the corner here. Let's see whether or not the output is self-explanatory. We have an array 3141, which is what we indeed expected, and we do plan to partition it, sort the entire thing, and we want to partition this stuff starting at 0 and ending at 3. In other words, we want to partition the whole thing around 3, and the resulting array, 1134 over here, is exactly what we would hope. And the pivot, 0, 1, 2, that's what we would hope too, because pivot 2. However, the next thing that happens is we're taking the array 1134, which has been lovelily partitioned, and our start is -1 and our end is 1. This looks like the second part of the so the question is, where is this call being done? Is this being done, a naive interpretation, and possibly the correct one, is that the next time we see this printed is the first time we see this printed is here, and the next time we see this printed is on this invocation. But I don't think that's necessarily the case, because this quicksort is recursive. So this quicksort recursive call comes along with start and pivot. And start and end. start of -1 and an end of 1. That's our interesting thing. Clearly, that's going to cause a problem. Because our convention is that the start and end values have to be acceptable indices into the array, and -1 clearly is not. And so at the outset, trying to partition 1, 1, 3, 4 with the start of -1 and end of 1 is wrong. What we should have hoped for here was a start of 0 and an end of 1. And I'm just a little surprised that we ever got a smaller value for the start. And so when I look over here, the first thing that happens after this line 25 is line 26, which is an invocation of quicksort with the array. The start and the pivot, the start should still be 0. Oh, that's these decrements. In order to be compatible with Corman-Lyserson and Revest, I've sabotaged myself here. I know that much. Now I'm going to have to think about how to fix that. So I need more thinking time. You should think too.